Hello everyone, welcome to a new semester. My name is Çağrı Mert Bakırcı, but you can call me Chuck, it's easier. And in this semester, in this lab, we will be learning MATLAB as an introduction to programming. We will do that because, as you probably know, nowadays programming is a very important skill that everybody is trying to learn, especially the younger generation, because computers are everywhere in our lives and we can program them and make them do things which simplifies our lives. And more importantly, programming on its own can be a skill that you can use as a job. So yes, you will be probably engineers or whatever department you are going to pursue your undergrad in. But if you know programming really well, what you can do is you can actually become a good programmer and work with people or on your own and make money with that skill. So programming is like one of the big things that probably everybody is trying to learn and in my opinion should at least know the basics of. And we will learn it with MATLAB, and if you are into programming, you might question that. Why do we do that? Especially in a time where there's so many very powerful programming languages. Well, MATLAB is one of them. It is one of the most powerful scripting languages that you can find out there. And scripting languages are kind of like programming languages, but they're not used to actually program the computer itself, but rather use the computer's computational power to solve problems, to automate things and things like that. And MATLAB is actually one of the most powerful one of those, as I just said, and it is a very, very efficient tool in solving complex equations, for instance, or modeling your systems that you're going to see in engineering, which brings us to why actually we use MATLAB. Because we are engineers, we are not programmers. Programmers or computer scientists, they develop languages to command the computer. We rather use those tools, or we use programming as a tool to make the computer do things for us and solve our problems that we face in engineering. So for most of the computer scientists or people who are experts on computers, the programs, the programming languages, the algorithms are the key or are the main goals for what they actually want to do. But for us, it's just a tool that we use to make our lives easier or solve our problems, and that's why MATLAB is a great software that we can use. Because it's very fast, because it's very, very easy to learn, and because it can do everything that pretty much any other programming language can do, but it's maybe not as good as, C, for instance. Everybody knows that C is a great programming language, and it's the most widely used one in terms of actually programming computers, but it's very difficult to understand, especially some important, crucial parts of C. But in MATLAB, it's so simple to understand what's going on. It's so simple to understand where you write what and what it exactly does. So it's great when you're first learning programming from scratch, unlike maybe other languages. Well, you might ask, why not Python, for instance, which is the rising star of programming languages? And that would be a very good question. Python is a great first programming language, and I strongly encourage you to learn Python. But we have been teaching MATLAB because, again, for the same basic reason, we are engineers and not programmers, and especially for mechanical engineers, Python, MATLAB is a great way to go. Why? Because MATLAB comes from Matrix Laboratories. It's an abbreviation for Matrix Laboratories, and why that is because MATLAB uses matrices as its core calculation unit. And as you'll see in your studies in engineering, that being able to represent something with a matrix is pretty much what we do in engineering. So it is an extremely compatible tool to use, especially for engineers, because it's very easy to manipulate matrices since it's built on matrices. It's very easy to solve systems of equations and, you know, represent engineering systems, let it be mechanical engineering, electrical and electronics engineering, and all sorts of engineering. And it can also do a lot of the things that other languages can do, so we are not really losing much. So it is a great first language to start with. And then, of course, you should branch out to Python and even C, maybe C++, and all that, like Java. And if you're interested in, like, you know, websites and stuff like that, you can learn PHP, Angular, JavaScript, and all that. Of course, there's a wide array of programming languages that you can learn to build things. But MATLAB is a great tool for our purposes. So what MATLAB does is basically it speeds up any calculation that you can make on a piece of paper or even using a calculator, because you program the computer and you use the cores of the computer, the processing power of the computer, which can exceed billions of calculations per second. So we get our results faster, more accurately, and all that good stuff. Because if you can't get accurate results and get them fast, you will fall behind, or you can actually cause catastrophes as an engineer in your future life. So programming is the core thing actually in engineering. Of course, you're going to build your basic engineering skills around it, and you will have some independent things, skill sets that you will use, but programming will always go hand in hand with those other stuff like, you know, statics, dynamics, machine theory, and all that. So in this class, we will be looking at MATLAB. We will have some problems to solve with MATLAB. We will actually have, if you don't count this very zeroth lab, as we call it, we will have 12 labs in this semester. And each of those, we're going to learn the basics of programming using MATLAB. And the nice thing is, everything that you learn in this class can be used in any other language as well, Python, Java, PHP, whatever, because this is the core of programming. And again, as I said, MATLAB makes it easy. Let me give you an example. You know, one other thing that's rising nowadays is online lectures and classes, right? You've probably heard of Coursera, Udemy, and all that good stuff. Coursera has a machine learning, you know, artificial intelligence class that is taught by Andrew and G from Stanford University. And, you know, machine learning, it is the top programming field, artificial intelligence field right now. And that class, for instance, uses MATLAB as an introductory lecture for machine learning. Why? Because MATLAB is so easy to work with, so easy to understand. You don't want to overwhelm the students who are already trying to learn something very complicated like machine learning. We don't want them to learn programming and machine learning at the same time. We rather want them to learn machine learning, and then they can improve their skills in programming, or vice versa. You can learn programming, and then you can build on your skill set. So it is a really well taught process actually, and that's why MATLAB is a great tool. And in our labs, we will learn the basics of this programming. We will look at like if-else statements, loops, functions, scripting, and all that. The lab's format is pretty straightforward. How I do it is I come to the lab every, you know, lab hour. We will have 2 hours of labs. And in the first hour, I let you guys do everything that is asked from you on the paper. So I don't take any questions. In the first couple of weeks, I will of course answer your questions because you might have some issues, you might not understand what's happening, or you know, you're trying to adapt to this new course. So I will answer more questions. But after like the second week or so, in the first hour of the class, I will not accept any questions. Why? Because I want you to struggle. I want you to figure out the codes on your own. Because unlike some other classes that you're going to see in engineering and in other undergrad studies, programming is something where you need to actually force yourself to figure out how it is done. And once you figure it out, everything else will come very easily. That's like the key of it. There's like this clicking moment in programming where you say, aha, this language works like this. And then everything comes very easy. And if someone shows you, even if they show it to you for weeks, you won't understand anything unless you actually force yourself to come up with solutions. That's why I will not let you ask too many questions in the first hour, so you will try it on your own. And in the second hour, and in the meantime, in the first hour, I will like grade your papers from previous weeks and stuff like that. And in the second hour, we will interact more. You can ask your questions if you struggle, if you got stuck somewhere, and I will give you your papers back, graded papers and things like that. So we're gonna divide it to two like that. So how I do is basically like this two-part type of thing. And at the 50th minute of the second hour, you should have submitted everything to Blackboard. Because let's say you enter class at 10 a.m. So 10 a.m. and the class ends at, or the lab ends at 11:50, right? So by 11:50, you should have submitted everything to Blackboard. Because I will let you submit until 12, so 10 minutes after the class actually ends, and you will get no penalties. But after that hour, after the 2-hour ends, you will be penalized. You will have 30 more minutes to submit your work, but you will penalized for the late submission. And after that 30 minutes, so if you enter at 10 and if the class ends at 11:50, I give you until 12 for with no penalty, and then I give you until 12:30 with penalty. After 12:30, the system will shut down. The Blackboard lab will not be visible to you anymore. You won't be able to submit anything and you will get a 0. So make sure you submit at least something by the end of that penalty time. And if you don't want to be penalized for late submission, make sure you submit it within the first 2 hours. And in every lab, you will have some submission going into Blackboard. So how this works is we have the lab sheets, and every week I will give you a lab sheet and you will read the questions on it. And each of those questions will tell you to do some stuff and you will work on those. They are adjusted to be to take like 2 hours. Maybe in some labs you will be done in an hour, actually. In some of them it will take about 2 hours, so you'll have to hurry a little bit more. So come prepared to the lab. You won't know which one is harder, which one is easier, and it will depend on your skills too. Somebody can be done in the first hour, but it might take you 2 hours for you to finish. So make sure you come prepared to these labs, and you will work on those things. As I said, in the first hour you will work on your own. But our labs are a little different. Actually, you can whisper to one another. We don't consider that cheating. So if you got stuck, you can ask your friends, like your neighbors sitting in the lab, like, how did you get this? Or I got stuck here, can you help me? And if they want to help, they can help you. But, so whispering is okay. But if you take a picture of somebody else's code, if I see you receiving a code with email or on your phone and you just type that, I will consider it cheating and you will be kicked out of the lab, basically, and you will get a 0 from that lab without a warning. So I will not warn you. So don't cheat. Don't take a picture of other people's codes. Don't receive codes or send codes to others. But you can talk, so we let you do that. So you can like, oh, okay, I see how you do it here. Let me do it on my own. So at least it will like give you a hint, basically, that little chat, and you can maybe figure it out on your own. So that is okay. And we won't allow you to collaborate like this in obviously the midterm, but also in the project. Project is your individual work. You should not look at others' codes, and you should probably not even talk to other people about their codes. Why? Because programming is a little different than, again, other classes. Everybody has their own signature. In that signature, by that signature, I mean how you write a code is very specific to who you are. And it is obvious when two people talk to one another or write similar codes that they cheated from one another, because it's highly unlikely that you can actually write the exact same code without talking to one another. And unfortunately, when people look at each other's codes, they memorize it. They tend to memorize the steps, and when they go back, they write the same thing, and that's cheating. So you can't do those things. You shouldn't do those things for the projects, and technically in the labs too, but we allow you to talk and write your own code. So these are like the basics of the code of the lab. And at the end of the second hour, as I said, before the second hour ends, you should have submitted everything that you have. And in each lab paper, at the end of the paper, it will say you're going to submit this M file, this PDF file, and so on and so forth. So it will tell you exactly. And in the paper, there will be some checkpoints. Those checkpoints are either going to be code checkpoints. So you wrote a code and I need to come and see what your code does. Or the second type of checkpoint is what's called Cody checkpoint. Not code, but Cody checkpoint. Cody is a software that we use, which is like MATLAB. It is actually, MathWorks make that. So MathWorks is the company that makes MATLAB. And it basically checks whether what you wrote is actually correct, doing the correct thing or not. And I'm going to talk about it a little bit in the in a minute. Actually, I will talk about it. But this is the general scheme of basically how our labs work. So one thing about these labs is the lab, like the actual room that we do these labs, is not operated by mechanical engineering. It's operated by the IT department. What that means is we don't have control over the computers, and IT people, they want to regulate the computers using the software called Citrix. Citrix is a software that makes IT people install software in a single main computer, and it basically clones these to all of the computers in the lab. So it's like a centralized system of installing software and things like that. So you won't have MATLAB in the lab computers. You will have to connect to Citrix, and you will have to go to MATLAB from there, and you will use the central computer to do MATLAB stuff. What that means is if you try to save your work in MATLAB, if you're using Citrix, it's going to save it to that remote computer, not to the computer you actually use, but to the computer that actually the MATLAB is running on. So what you need to do is two things. You either have to activate your RaiderDrive. RaiderDrive is a tool that Texas Tech University gives to you. It's like Google Drive or Dropbox or Box or whatever you use. So it's similar to that. It's for the network within Texas Tech University. And if you save your work in that RaiderDrive, then you can save it to it, and then get it from the computer that you're actually using. So because those Raider drives are connected to one another, right? But if you don't save it, if you save it to my computer in the lab computer, actually that is not the computer you're using. That's the remote lab computer. So it won't save to your computer. So when you go to Blackboard to submit your stuff, you won't be able to find it because that Blackboard is seeing your lab computer that you're using. So RaiderDrive is important. Or if you don't want to use RaiderDrive, you'll have to carry a USB stick, because when you plug the USB stick, both that remote computer and the computer that you're actually using in the lab can see it. So you can save your work to your USB, and then it will let you do the same thing basically. So that is the main thing that you have to do. If your RaiderDrive is not active, take this week to make sure your RaiderDrive is active and that you can see it on your computer. You will have to map that RaiderDrive to your computer, and IT department has some explanations on how to do it, and if not, I will help you in the lab next week, but you should be able to figure it out on your own. So either RaiderDrive or your USB stick. Or there's another option. You can bring your own laptops to the labs. That's all right as well. And then you have no problems. Just install MATLAB to your computer. Make sure you have an actual copy. And then you're good to go. You don't need any of these gimmicks, basically. And there's another way. There's a newer way of solving this problem. There's this thing called MATLAB Online. So it is pretty much MATLAB running on in a browser, a web browser, or a website. So you can go to MATLAB online, but it is a little different in the sense that you have to actually download the things that you download your work instead of just saving it. And it's a little bit more difficult to do. It's not too hard. I mean, it's just pretty much clicking on buttons. But for every M file, you have to click on that download button separately, because it can download one file at a time. So if you're working on like 6 files, which we will in the like 6th, 7th lab, so you'll have to download them separately. But it can be done. That's another option, but it might not be that reliable. And Citrix is not very reliable either, but we have to use it. Sometimes it just crashes, and then, we have to either cancel that lab and do it some other time, or you'll have to do it online. So, but we can't really help that. So if you have your laptop, you're good. If not, you'll have to use Citrix. If not, you'll have to use MATLAB online. So that is, again, Citrix and RaiderDrive. Those two are important. And that's actually pretty much it. Now I'm going to show you some basics of MATLAB, thinking that you have no idea how MATLAB works. And I will show you our Cody as well, what it actually does. So if you're ready, let's just get started. Let's just dive into MATLAB and see how it works. I'm going to make myself a little smaller here because you don't need to see me really. And I'm going to put it to the side screen. Okay. So I am using MATLAB 2017A. You might not be able to see it. It's a little up here. But it is the newest version of MATLAB. Our computers have, I believe, 2015 or 16, maybe 17 now they might have installed it. Doesn't matter. As long as it's newer than 2015, you're good to go. It's the same thing. Doesn't really matter. When you first start MATLAB, this is the screen that you see. At the center, well, you might not see it this big. I just made the fonts bigger so that you guys can see, but pretty much this is what you'll see. At the center, we have command window. Command window is like a grand calculator, and we'll come to that in a minute. On the right-hand side, we have our workspace, which actually keeps a track of our variables and things like that, which I'll come in a minute too. At the bottom, we have this details. That's not really that important. It just shows what your files actually contain. And over here, we have our current folder. And current folder is where MATLAB is running right now, where it's looking at, where it's trying to find your M files, your code basically, and we'll see that in a moment too. So among these, obviously the command window is the most important thing because that's where you can actually enter things. So it's, as I said, it's like a calculator. You enter some stuff and it calculates it for you. And the first thing that you might have noticed is it calculates it, and then it puts it in the workspace. And ANS is a variable. It's a default variable called answer, basically. It's an abbreviation for answer. And ANS is 124. And as you can see over here, ANS is 124. So it just stores that variable. Now, instead of that, you might want to define your own variables. And before that, maybe we can just show some complicated calculation. And there's an operation precedence that you will learn in the class. I'm not going to go into it right now, and there are like little commands like square root. This is a function that's a built-in function, square root, SQRT. And one thing that's nice about MATLAB, it's a high-level language, which means is that what it means is it's closer to human language than it is to program, like the computer language, right? Like ones and zeros. It used to be like people used to use languages like assembly. And before that, they actually used punch cards, literally pretty much ones and zeros or hex codes that is installed to the computer. And that's what the computers could understand. That's still what they can understand, but we don't have to talk in that language. We can talk in a little bit more complex languages. Like assembly is actually very similar, very close to programming language. Then there's a computer language. Then there's C. It's a mediocre language, I would say. It's a little higher than assembly, so which means it's closer to human language than than assembly, for instance. but still it's not there yet. And then there's Python and, you know, MATLAB and even higher languages like Wolfram, Mathematica, things like that. In Wolfram, for instance, you can literally write sentences, English sentences, and it will understand what you're trying to do, pretty much like Google understands what you're looking for. So it is pretty neat. But as you go higher, the level of command you have on the computer's chip, basically, the mind of the computer, is kind of lower. So you lose some in that, but it's easier to write, and sometimes it's not as efficient in the sense that how it calculates things. I mean, higher level languages are not that efficient because these codes that you write in high level has to be converted into machine language, ones and zeros. So that's why there's some inefficiencies there, but it's more efficient in the sense that we can write things faster. So we can, you know, we can afford to lose some in the translation to computer language, and obviously we have very powerful computers nowadays, so that loss is not even a big loss. So that's why MATLAB is a high language. It's closer to English, and as you can see, square root is sqrt. And then within built-in functions, you just write what you want to do. So I want to take square root of 67. And the moment I hit enter, it just calculates it. And as you can see now, ANS over here has changed. What does this mean? It means that ANS is overwritten. So variables are things that can be overwritten. So if you don't want to lose them, you need to make sure you're not redefining a variable. So let's first define a variable. To define it, we use a equals, for instance, 34. So when I write it and hit enter, as you can see now, it's not ANS anymore. It is a, and my a is 34. One thing like about variable definitions is we literally write like b or whatever equals, and then we can make a calculation like, and we can use the things that we already defined. For instance, a divided by 3. Okay? And if I hit enter, it will just calculate it based on what a was, and it will calculate b. So never forget this. In MATLAB, b equals a divided by 3 is technically not a mathematical definition. What does that mean? So b equals a divided by 3 is the same thing as 3 times b is equals a, right? This is the same thing. I just moved 3 to the other side of the equation. But this wouldn't work in MATLAB. Why? Because in MATLAB, the equal sign is not a mathematical equal sign. The equal sign is an assignment sign. What does that mean? The left-hand side of the equal sign is what the variable will be. So let's fix this. Let's say c equals now a plus b. So here, c is what I'm trying to assign something to. And everything to the right-hand side of the equation sign or equal sign is the knowns, is the action that you want to take, is the thing that you want to assign to the thing on the left-hand side of the equal sign. So everything to the right-hand side must be known. What does that mean? It must be defined before. So if you're going to use A and B must be defined before. For instance, if I write here D, this won't work because D is not defined, and I'm going to show that to you in a moment. But everything to the left-hand side must be just a variable. It can't be a calculation. It cannot be a calculation. It just needs to be a variable. So what are variables? Variables are basically names that we use, and there are rules for those names. A variable can start with a letter, and it can contain letters, but it's case sensitive. So for instance, car is a different variable than car with a capital A in the middle. So those are two different variables. And it can have numbers in it, like this, car 34, but it cannot start with a number. So a 34 car is not a valid assignment or a valid variable name. It can have it in the middle, or it can have in the end, but not at the beginning. And it cannot have special characters like summation sign, for instance, or multiplication. It cannot have those. The only special character it can have is the underscore. You can use underscore 34, 32, for instance. that is a valid assignment. And if we see this is a valid one, for instance, if I do it, as you can see, car34 underscore 32 is a plus b, whatever a plus b is, and a is calculated from here, b is calculated from here within our workspace. So high-level languages, I said MATLAB is a high-level language. One nice thing about them is if you do something wrong, like this is not a valid assignment, right? Why? Because on the left-hand side, I define a variable, but it starts with numbers, and it can't start with numbers. Let's see what happens. As you can see, it didn't calculate it properly, it just saw it as 34. Or, let's see it even better, d times s equals a divided by b. As I said, you cannot have calculations to the left-hand side of the equation. If you have calculations to the left-hand side, you have to leave the unknown on its own and move the known ones to the right-hand side of the equation at all times. But if you forget that, as you can see, it just, in the newer versions, apparently, it doesn't give you that error that it used to give. It says incorrect assignment on the left, to the left-hand side of the equation. Nowadays, I guess it's a little smarter than that, but it says, so it basically ignores the right-hand side, but it doesn't do what you're trying to do. So you have to make sure you use correct variables. But if you read the error, it makes sense, right? Undefined function or variable d. It's not like something like, you know, how Microsoft sometimes gives weird errors, like, you know, 0x000f error something something, you know, DCHK, some like this code. It doesn't do that. It makes perfect sense. This is also because it's a high-level language. Its errors make sense. Just read the errors. If you get an error, don't be scared. Just read the red, you know, words written in red, and you will figure it out. I guarantee it's easy to figure it out as long as you read it. And if you get stuck, let me know, but you will figure it out if you read the errors. One neat thing about so let's just do something wrong. For instance, let's say ff23 equals, and as you can see, variable names should make sense. Like ff23, what is that? I don't know what it is. But if it's tension in 2-3 direction, it makes sense. Or you can say t maybe to make it shorter. So you need to think it carefully. And if you don't want to worry about underscore, just don't use underscore. And, you know, make sure your variables make sense. And then you make a calculation, right? And then you use something wrong. You use d, but d is not defined. Let's see what happens. Again, the same error. Undefined function or variable d. And then you say, I forgot to define d. So let's just define d as a times b. And as you can see, let me teach you something else here. Whenever I type a line of code, it spits it back at me, the result. I might not want to see it. Like, this is an intermediary step. Let's say in my longer calculation, I don't want to see it. Don't show that to me again. So if you don't want to see the result of one of your codes, you just put a semicolon. And semicolon is one of the most important things in this lab. You need to know when to put a semicolon and when not to put a semicolon. If you want to show the result of the code, then you don't put a semicolon. This is called suppression. You don't suppress your code. You want to show the result to me, for instance, because I'm going to grade. But if you don't want to show a result, then you suppress it by putting that semicolon. How do you know it? Again, intermediary steps. You suppress them because they are not the actual results. The final line will give you the actual result. So you put semicolons in the middle and you leave the last one open without any semicolons, so we can see the result of that final line. And you will figure it out in time, which is your results and which is not a result for you. But at the beginning, in the first couple labs, it might be a little difficult since the problems that we're dealing with are extremely simple. So don't worry about it. I won't be too harsh on it, but at least try to figure them out. What is a result in this problem? Think about it. So back to this. I define my D now because it was undefined. Now I want to redo this line of code again. You don't have to write the whole thing again. All you need to do is you press the up key in your keyboard, and this is a list of your previous commands. You can't see it on the screen right now, but if you do it in a MATLAB, you will be able to see it. And you go to the line that you wrote that you want to repeat, and you want to see the results, let's say this is actually your result, so I don't want to put a semicolon, and I hit enter. See, that error is gone now because our D is defined. So this is how variables work. So you can use them in all sorts of ways. For instance, factorial, right? Factorial is a built-in function. How do I know it? Well, with experience you learn it, but if you don't know how to find a function, what you do is extremely simple. You go to Google. You go to Google and you type MATLAB factorial and find what code you need to use, what built-in function you need to use for factorial. It is okay to go to Google. Even the best programmers in the world use Google extensively to look at the community to see how they solved a given problem, if they encountered a similar thing or if there's something that they don't know. Google is okay. You can access information. That's fine. So, but there's also this FX button. It is the built-in function finder. I don't think you'll be able to see if I click on it. Let's see, because of how I record this. Yeah, you can't see it, but play with it. Just click on it and type factorial and see what it gives you. I just type factorial, and there are list of functions that does what, you know, that is about factorials, but you need to use the ones that doesn't have a parentheses next to it. The ones with the parentheses next to it are for toolboxes. MATLAB comes with a lot of toolboxes. Up here, it's called apps. And if you go here, you will see like neural nets, for instance. There's a toolbox for machine learning. There's a toolbox for curve fitting. There's a toolbox for system identification or PID controls. For finance, for signals, lots of toolboxes. We don't want to use them. We want to use the basic core built-in functions of MATLAB, and those are shown in this FX button as things that doesn't have brackets next to it. So just use the ones that are without the brackets. So I now know, okay, it's not fact, for instance, but rather it's factorial. And then you can use, like, I don't know, 34. It's such a big number, but with one enter, you can figure out the result. So this is pretty much it. But one thing that you might have recognized is I keep typing stuff and these things get lost. Like they're like, you know, long gone. I mean, it's all the way up there. And every time I hit enter, it just calculates it. It's, you know, I can't go back to this and edit, oh, I don't want to do this. Actually, it's 2 times A. No, you can't go back and type it there. It's so annoying. So that's why technically we never write our code in the command window. Where do we write our code? We write it in the editor, because editor, which I'm going to open now, is where we actually write our code and then we run it to see the result. It's like a text window. Let's see that. So you go to home button here, and here's a new script button up here to the left. It's a little small on your screen, but it is this button, as you can see. So you click on it, and all of a sudden it creates another window, which is the single most important window in MATLAB. This editor is very much like command window. You write your code in here, but when you write a code, let's say F equals D times A divided by B, and when you hit enter, it didn't calculate it. Why not? Or how do I know it? Because it's not over here, as you can see. There's no F. What does that mean? Editor does not calculate as you write stuff. And that's nice, because I can go back and say, oh, I did it wrong. It's 2D times A divided by B. So how do I run this thing? I literally go ahead and hit run. I say, okay, I'm ready for my code. I want to see the result. Go ahead and run. When you first run a code and you open a new script and you wrote your code in it and you want to see the result. When you're running it for the first time, if you hit this, it's going to ask, where do you want me to save it? Go find a folder, and this is where you need to save it. If you're using Citrix receiver in our labs, you need to go to your R drive. You need to find it in under this PC, and you need to go and save it under there, or you need to find your USB stick and save it in it. If you save it to CD or your desktop or your documents, you won't be able to retrieve them when you're trying to upload them to Blackboard, because it is on a remote computer. It's not on your own computer. Don't forget that. This is why if you're not using your own computer, you need to use the RaiderDrive or your USB stick, or just use your own computer so you don't have to deal with this. This is my own computer, so I can literally save it in desktop under MATLAB class. And here you're going to type a name for this. And I'm going to type lab 0. And the moment I save it, it can ask if your current folder is actually not your... So for instance, if I go to my desktop and if I hit run again, you will get this error. So if you're not in the folder that you actually saved your file in, it's going to say, do you want me to change the folder and go there? Or do you want me to take that code and edit to the current path, which is shown here under desktop? You want to add to there, or you want me to go and find it? We always choose, most of the time at least, we choose change folder because it knows where it needs to go. So I'd say change folder, and it goes there and it automatically runs it. Whenever you hit run, if it asks you to save or if it asks you to change the folder, when you click to do that, it also calculates the result. And you can see it here, f equals this, and you can see it here. Now it's doing what it's supposed to do. And I can go back and say, oh, okay, I did it wrong. Actually, it was supposed to be 3, and actually it was supposed to be divided. And I hit run again, and it recalculates my f value, and it shows it here. And if you don't want it to show the result, you make another difference, let's say 2 times. And you can't type 2a, unlike mathematics again, because this is not mathematics, this is a coding. If you type 2a, it won't understand it. Let's see what happens. If I run this, it's going to say unexpected MATLAB expression. Again, read the error. Very clear. Unexpected MATLAB expression. So and it's underlined. So you go there and say, 2a. It needs to be 2 times a. And I don't want to see it, so I suppress it. And I hit enter, I hit run. And it runs it, but it doesn't show anything. How do I know it's changed? F is now the different value. So this is how you write your code. Then why don't we write it in the command window? What will we do with the command window? Well, command window is just a quick calculator. It's not for coding. It's basically used for 3 things. 1, you see the results, or you see what's going on. You see the errors and stuff like that. As you saw, when I do this, it gives an error and you read it in the command window. That's the first use. The second use is actually, you see the errors and you see your results. Those are like 2 different things. And one other thing why we use command window is to quickly test things, or if you're not sure what you are supposed to do, you go ahead and use that. Like, for instance, factorial, right? Let's say I didn't remember it. I thought it was like factor or facto, for instance. Let's say, I don't know, facto 5, right? Or 3. So it's supposed to be 6. So if it does something else, you will know, because factorial is like, if it's factorial 3, it's 3 times 2 times 1. If it's factorial 5, it's 5 times 4 times 3 times 2 times 1. So facto 3, and you tried it, and it says undefined function or variable facto. Oh, okay, it wasn't that. So did you mean factor 3? Did I mean that? Factor 3? No, because it was supposed to be 6. So that is not it. Maybe it's factorial 3. Factorial. See, these types of things. Quick trials and to figure out things pretty quickly. And then you go here and say factorial f, and you assign it to a variable. And let's say you want to see the result. You hit run. Unexpected MATLAB expression. Oh, I forgot to fix this. See, it's underlined. The parse error at A, usage might be invalid MATLAB syntax. So there are these red ones, as you can see. Those are errors. Those will give you errors, so you need to fix them. And there are these orange ones. Orange ones are warnings. They will run without problem, but there is something that you can fix. And these things, you should know them. What's wrong with them? If you hover over it, over here if you want, or over here if you want. It says, terminate statement with semicolon to suppress output. How clear could it be? I mean, I just taught you that semicolons do this, and it's the exact same expression. So that's how MATLAB makes things easy. It's so easy to understand what's wrong. It recommends you to suppress it so that you don't flood your command window, because your code might be thousands of lines, right? and you don't want to see everything. So you can fix these things. And those are important because I'll talk about Cody in a moment. And Cody will kind of check these types of things. How accurate your code is. How good you have written your code. So if you can fix these warnings, you can pretty much fix or pass Cody without any problems. And you will need to pass Cody. Why? If you remember, on the lab sheets, there is the code checks and there is Cody checks. I will come and sign those in the second hour of our class. Not in the first hour, in the second hour. I'll come and sign those. And you will need to call me after you pass those Cody assignments. And we're gonna come to that in a moment. So, okay. We got that down. That's great. And now, you can keep writing a code. So also kind of another way to use command window, you can run quick codes. Like if you want to see how crowded this command window is. I want to get rid of those things. I want to clear it out. You can write CLC. That's a command that you will just learn in time. And now you just learned that CLC clears the command window. There you go. Now there's nothing. It's just clean. And let's say I want to clean this workspace. I don't want them to be there. Clear does that for you. If you hit clear, oops. Now the workspace is gone. Now, if I hit run, will this code work? Think about it. Well, there's a little error, so let's fix that quickly. If I run this code, will this work? No, it won't. Why? Think about it. Let's see. Undefined function or variable D. Now we're seeing something else. Well, yeah, okay. It's obvious. I didn't define D, A, or B because I just cleared my workspace. And that's the crucial thing. If something is not in your workspace, it's not defined. Unless it's like predefined things like pi. We never say pi equals 3.14 because pi is defined in MATLAB. So if you say 1 times pi, it will actually give you that. So that is clear. So let's clear this again. Clear CLC. So, okay, D didn't work. And let's run it again. Okay, D didn't work. But why does it not give an error for A or B? Because MATLAB reads your code from top to bottom to the left, from left to right. Just like how we read a book, right? It's very simple. So what it does is it comes to F and it knows it's not defined, but it's on the left-hand side of the equation. So there's no problem. Great. And it says, okay, F is about to be defined. I'm good with that. Equals 3. That's fine. Divide. That's fine. D. It goes to your workspace. It doesn't find D and it gives an error. It doesn't read anything else over here. That's why it gives an error at D and not at A or B. Okay, so what you need to do is, since it reads from top to bottom, let's try this. Okay, let's define D equals 14. Will this work in the light of what I just said? Or where will it give the error? Will it give it at D or A or B? It's going to give it at D again, and it won't work. Why? See, it again gives me the same thing. Because D is defined after where it's first used. That can't be done. It needs to be before, like this. Now, will it run? No, it won't run because there's still problems. But will it give an error at D? No, it won't. It will give an error at A. Let's see it. As you can see, undefined function or variable A this time. Because D is defined, that's good. A is not, and B is not. So let's fix all of these. And as you can see, I'm putting semicolons because I am defining them. I don't need to see them again. And now I can use A times 2 divided by 0.87. Okay? And now let's see what happens. Now everything is good. A is defined, B is defined, D is defined. But factorial this time gave an issue. Why? Because read the error. N, within factorial, it gave an error in factorial. N must be an array of real non-negative integers. But what is F I am using? 0.0466. It is not a integer, non-negative integer. So, okay, let's just change this to square root so we don't have any issues. Run it. There you go. G is calculated and everything is perfect. And this is how I can just go back and change and nothing is lost here. That's great. So what we do in our codes is at the beginning, we add a courtesy code called clear CLC. This is pretty much literally courtesy to other programmers. When I take your code as a grader, as your instructor, I'm going to run your code in my computer. And I will have run 10 other codes before you. And my workspace will be filled with previous codes. So they might overlap. So what we want to do is we want to first clear the workspace because our code will come. I mean, if my code is right, I don't need anything in the workspace. I will define them in a moment, so I don't need anything. So we clear the workspace. When I run, it will first read that. We clear the command window of the person, so it's a courtesy to them, right? They will see our results, and it won't just be filled. And the space doesn't do anything, and then my code will run. Let's run it. There you go. As long as you run it, it will go. And if we just unsuppress this to see a result, see, G is here. Now, if I hit run again, will it just put another G underneath it, or will it be just like this? Think about it. Will it be just like G equals here, instead of G equals this and G equals this again, because, you know, I'm running it again? It will be just this, because every time it's going to clear the command window. See, there's nothing on top of it. If you use the wheel of your mouse, you won't see anything else, because CLC clears the command window and reprints it. And it's how fast it is. It's milliseconds. It can calculate everything. So clear CLC will be in all of our codes. And there's another thing, close all. This won't be very important at the first few labs, but close all closes all the windows that are in the background that came from MATLAB, like figures and plots and animations and stuff like that, which we'll do in the future. So that when you run it again, it won't be in the background, so this main window won't block it, but it will be closed and reopened, so it will be in the front. And if you add close all, it will make your life easier. So these three are pretty much in all of our codes. They're not related to the rest of the code, it's just for courtesy. And let's see some other stuff. Commenting is extremely important. Semicolons is the most important thing, and the commenting is the next most important thing. You will write this code, you will go take a vacation for 3 months, you'll come back and you will forget what these are. A is 3, but what is A? So we want to put comments in our code, which are like words and sentences that we can write. So we can just look at them and see, this is it. For instance, A is the tension on the rope. See, when I did that, what it does is I put a percentage sign, and everything to the right of the percentage sign is a comment. So this whole thing is ignored by MATLAB. When I run it, it won't do anything differently. So because it doesn't read these. So you can come here and put a space and put B is the friction factor. I don't know. I'm just making stuff up right now. But as you can see, I can comment. Or you can comment like bigger things like rope, or let's say like problem 1. Right? So this is commenting. But there's one more level of commenting, that's sectioning. Sectioning is pretty useful for 2 things. One, it makes it look nicer. So you put double percentage and a space. If you don't put the space, it won't work. If you just write like this, see, it went away, that yellowish background. And I'll show you what that means. You need to put a space, and then you write lab 0, introduction to programming with MATLAB. Then you put a single percentage sign and you write your name. My name is Çağrı Mert Bakırcı, and you can call me Chuck, as I said. And you're gonna write your section, 30X, something, 301, 302, 30X. You can say section. And you write the date, month, day, years. Okay? So this is the third most important thing. Semicolons, commenting, and this is our H1 line, as we call it. H1 line is extremely important because it allows us to see who wrote that code, right? It's very important. In every single M file, we will ask you to write this. You can copy and paste from previous one and then just change it to lab 2, lab whatever. So, and this part, of course. But you need to write this in every single code. You need to comment In every single problem, I want to see at least one comment. At least one comment. If you don't have at least one comment, you will lose points for poor commenting. So for every single problem in your lab sheet, I want to see at least one. If you write more, it's better. So, because you will have to get used to it. And it will be difficult at first, commenting. Because they're so obvious, you won't know what to write. Just write, this is a number, right? I mean, I just made up something. So just write something, right? Say hello, right? It's okay. It's not a problem. Just so you get used to it. And you see how I use like this spacing? Use that. Spacing, architecture of your code is important. We want to make sure your code looks nice and easy to read. So sectioning, I just sectioned this and it's a huge yellow block. I don't know what it's doing. Let me show you what. So in the problem 1, you just put in a second percentage and then it will section that part out. Now we have 2 sections. What does this do? One nice thing about sections is if you right click, and you can't see it on my screen again, but there is evaluate current section in the middle, or you can simply use Control Enter. And it will just run these 3 things, or this section, only this section. And again, this is not red, these are comments. Sections are technically comments too, but it just runs this, but not these. As you can see, there's nothing calculated. And then you can come down here, right click, and go to evaluate current section, or just Control Enter, and then it will run only this. So if I run this again, just this section, now I'll see 2 G's. Let's see. See, there's another one because this part is not running, and the person's command window is not clearing. So every time I run this, it keeps running it. But if I go here and run the whole thing, then it will run the whole code. If I click on this run, and then it will clear my command window. Now there's only one. It cleared everything else from before. So you can understand the logic there. So basically, this is what we're gonna do. We're gonna section our problems out, and then do like ZZ equals square root of 34, and you move on to the next problem, right? Tension equals ZZ times 2 divided by 5. And then you can run this section. And we don't use, see, it calculated tension. So we don't use at first we will use desectioning, and in the future we will move on to like separate M files for each problem. But as you can see, I didn't put clear CLC close alt before every problem. You don't do that. It's only for the at the very beginning, and it's only for, out of courtesy, basically, right? So you don't put it in every single problem, just at the very top. And so what is this sectioning? Now we need to learn something else. We will write our codes, and let's say this is done. Let's say this lab was just these 2 problems, and I'm done. I calculated everything, and I'll show something in Cody in a moment, but, you know, it's pretty much great. Now, what I need to do is I need to publish it. I need to create a PDF file using my M file. MATLAB has this very nice feature where it can create PDFs based on your code, and that's what I'm going to do now. You go to this Publish tab on top, and you will see why these sectioning are important in a moment. So you go to Publish tab, and you see this little arrow here. This little Publish and a little arrow. You click on it, and then Edit Publishing Options. So you click Publish, click on that little arrow, and Edit Publishing Options. I click on that, and I get this. You don't see it again on my screen. Sorry about that. But you basically get, let me see if I can. Yes, here we go. Now you can see it. You get this window, and you do 2 things in this window. What you do is you first click on this HTML, because that's the default setting. We don't want HTML, we want PDF. So you select PDF there. So you don't click on here or anywhere else. You actually click on that HTML, and then you go to PDF and select that. And the second thing is, this automatically wants to put it on a special folder that it is going to create called HTML. Just get rid of it. You don't need that. And you just click out of it, and it's going to be saved. So it doesn't create that unnecessary folder. If you forget that, it will put it in a new folder under where you're working. I'm working in desktop MATLAB class. You'll be probably working in RaiderDrive or your USB. It will create an extra folder in it. So if you don't want that, just get rid of those two things. So we get rid of the extension over here and we change this to PDF. And then you basically click publish. Now you wait for a few seconds. It might take a couple seconds for it to publish, and it's gonna give you this beautiful PDF with table of contents with pages and stuff. And see the part you sectioned, so this very top line is the title of your PDF, and you see your name and stuff here and your code, and your other sections are your subheaders. Very good. I mean, this looks very nice. This is a project report for you, created for you automatically. That's nice. So we want to use this, and you see the results. See, I suppress intermediary steps and I show my last line because probably that's the answer. I suppress using semicolons and it shows my final line here. Because I didn't suppress this, it shows my G, right? So that's the logic behind. So you will, in most labs, you're going to submit this PDF and your M file together to Blackboard. So make sure you read the bottom of the make sure you read the bottom of your lab sheet. Okay, and one last thing, that's Cody. Let's say in a problem 3, I needed to calculate the hypotenuse of a triangle. What is the hypotenuse of a triangle? See, I can't write h squared equals a squared plus b squared. Why? Because this is not maths. I can't write this special character over here. Let's see what happens if I just run this section, evaluate current section. See, it's here. Right click, or you can use Control Enter. Aha, read the error. The expression to the left of the equals sign is not a valid target for an assignment. I mean, how clear can it get? How clearer can it get? It's very clear. So, okay, what you need to do is you just need to manipulate it mathematically, so you can take the square to the other side as a square root. So you can say square root of this whole thing is my h. So that's the correct thing, right? Now, of course, you need to define a and b, but it is already defined. So let's not use a and b, but let's use x and y for this problem, so it's not associated to the problem 1. And I need to define them since I just am using them. Let's say 3 and y is 4. So I know my h should be 5. Let's see, let's just run this line again, evaluate current section, or you can run the whole thing if you want. Go back to editor and run it. It will run the previous codes too, previous sections as well. You can see our G here, or our tension from the second problem. But in the end, it shows you H. Okay, calculates it, great. So, you know, if I forget to type this, if I just type x2, it's gonna give me an error. Why? Because it will see this as a whole variable, right? Let's see that. And it will say undefined variable, as we expect. See? Undefined function or variable, x2, because x2 is a variable name, and it's not defined before, so you can go, oh, okay, I forgot the, to the, you know, caret sign there. But what happens if you forget to write, excuse me, if you forget to write, or if you just by mistake type 3 there instead of 2, will MATLAB give you an error? No, because what you write is syntactically, this is called the syntax of the programming language. There's no syntax issues, unlike this previous case where you forgot the caret sign. Everything is proper. This is a valid calculation, so if you run this, it will run and will give you the wrong error. So this is a simple problem. You know 3 and 4 should give 5. But what happens if you ran 32 and 46? Do you know what this is supposed to have? Let's run it. how do you know if it's the correct answer, if it's the hypotenuse, if one edge is 32, let's say, millimeters long, and the other edge is 46 millimeters long? How do you know it's just supposed to be 186.7726? You wouldn't know it. And you will encounter this in your lab sheets. We will ask you a problem for you to solve. And you will solve it, but you won't know if your answer is correct or not. That is why we need Cody. So for Cody, let's just go to Google. Cody is like MATLAB. So it is actually, again, as I said, it is a MathWorks product. And what it does is it is pre-programmed by us to basically check the accuracy of your code. Not the syntax of it, but things like, did you put a semicolon? So if I don't put a semicolon here, it will run. But I want you to put a semicolon there. I want you to learn. So Cody will be able to check for these types of things. That's why I said, if you can fix these problems over here, so it says, you know, you didn't put a semicolon. If you put a semicolon, you'll fix it. If you can solve those warnings, you will be able to pass Cody easier. So what is Cody? Let's just go and check it out. So Cody is, you basically go to Cody coursework in Google, and then you click on the first thing, and you need to have a MathWorks account, by the way, and you will have an invitation from our head instructor that you need to enter. So you need to enter your email address and your password, and you will have an invitation for this particular class. And let's just close this, and let's just say don't disturb us. See, I don't have an active course, so I'll go to a previous one very quickly to show you how Cody works. So you will have an active course if you accepted the invitation, and there will be assignments for your homework that are due Monday. This is for our head instructor to take care of. We are not charged, and we are not, you know, responsible for these assignments. We're responsible for the labs, but you are responsible for solving those every Monday or whenever the head instructor wants you to turn them in. But labs, we will, in pretty much in every lab, as you can see, lab 0, lab 1, lab 2, 3, 4, 5, 6. In pretty much all labs, you will have a Cody checkpoint. So I'll just show you one here very easily or very simply. You just go to whichever lab you are solving at that point during the class. You will do this during the lab hours. You will, once you hit that part of the problem, you'll go here, find the appropriate problem, and go to the Cody test. And it will tell you either on the paper or in Cody, it will tell you what exactly you should do. Here, for instance, here's our problem. Given the variable x as your input, multiply it by 2 and put the result in y. You know, as an example, if your input is x, your and it is 2, your output y should be 4. If x is 17, your output y should be 34. So since I solved this before, I mean, I showed it to the previous class in the past semester, I'll just say improve your solution, but you will have a solve button. You're going to click on the solve button, and we go to the problem. And as you can see, this looks like MATLAB, right? And it will come to you as this. So this is a function. We will learn about functions in the coming labs. Don't worry about it. But for now, what you need to know is you never ever touch this line or this line. So you never touch in Cody the function definition line, this very first line, and the end line, this very last line. You can change everything in between. You can get rid of them if you want. And you can solve the problem. I mean, you can write whatever you want. But you never ever touch this first line or this last line. So let's say this is my answer. See, if I type 2x, it is a syntax problem. Just like MATLAB, and you can test it. This test button is to like run. It will give errors, bad red errors basically. So, okay, I don't want that. But this, y equals x, is a valid syntax. So what is y, what is x? So in this function definition line, function tells you that, again, we'll learn more about these later. Don't worry about it. I'm just telling you so you have an idea. Function is tells MATLAB that this is going to be a function definition, and y is the output, what it's going to spit back out, basically. And that's why your final line should be y equals something, so that y will be defined and the function will spit out that y result, whatever happened in that function. Times 2 here is the name, and that equal sign needs to be there. And times 2 is the name of the function. So you can name it whatever, but here you don't touch it. And x is the value that actually the users, if this function was in MATLAB, when you write your code and give it to a user, they will use your function. You remember how I used here, like factorial, and then I opened up parentheses and I entered it a value? It's very similar. It's exactly the same thing. There is a built-in function somewhere in MATLAB folders where it says factorial, just like over here. It says function y or whatever equals factorial, open up parentheses, x. So a function is defined called factorial somewhere in MATLAB that comes with the MATLAB package as you install it. And you call it in your MATLAB and you give it a value, which is your x. See, I'm giving it a value as the user. I'm giving it a value and then it calculates that for me when I hit enter. It's very similar. If it was here, if that times 2 function was defined here, I would type times 2 and then give it a value. Of course, it won't run now because times 2 is not calculated. And you can see actually it works like Google. It says, did you mean this? But it's not defined, so it doesn't work here. But if it was defined, if you wrote the code and gave it to me, your code to me, I would have your code, which was titled times 2, and I would just give it a number and get the result out. But in Cody, user is the computer, the AI, if you will. It's like the smart computer that we actually programmed before. It's not AI, it's just, you know, I say AI, but it's not AI. But what you do basically is you just assume this, whatever is in this parentheses, it's given to you by the computer. So you don't have to define it inside your code. And if you defined it, you have to get rid of that. Why? Because I want to try new x's, new x values in your code. And Cody, think it this way. Cody knows what y you should get if it gives you a particular x. If it gives you 2, Cody knows the results should be 4 for this times 2 because we programmed it to know that. So basically, in MATLAB, if you were not using a function, if you were coding it here, let's go back. If you were coding here, what you would do is you would say x equals 2, and then you would say y equals x, let's say. And you would have to define that x. And it makes sense. It is correct. You need to, because if not, it will give an error saying undefined x. But in Cody, you don't need to do that because it's in parentheses here, and that makes it special. It will be given to you. So you don't have to define x equals 2 here. And actually, if you define that, you have to get rid of it. Whatever is given in this parentheses as the variable name, you need to get rid of those if you define them in your code. We will learn more about this, but whatever. But the main idea of Cody, what I'm trying to teach you actually here, is this. Cody knows the results for given x's. It knows what y values it should get. This is just an example. So if I don't have a syntax problem, I won't be able to know the actual result, whether the result I'm getting is right or wrong. So if you remember this problem here, when I run it, how do I know this is correct? So Cody knows for this x and this y, your h should be a certain value. So here our problem was to give it an whatever x comes, we need to spit out twice that. So if I run this, I forgot, as you can see, it's a wrong code right now, but it's syntactically correct. There's nothing wrong in the way it's written. The only wrong thing is what it does. And as you can see now, it's not a bad error. It just says assertion failed. And as you can see, it gave 1 and it expects 2, but you're getting y equals 1. It gave as x 11. See how it runs? I didn't define x, but it still runs properly because x is going to be given to me by Cody. This is the key thing you need to understand, but it will take time to get used to it. In MATLAB, you have to define everything that you use. In Cody, you still have to define everything unless they are already given in this parentheses because they will be given. You can assume that these things are defined. So assertion failed. It gave 11 and it expects 22, but you're getting 11. So something is wrong. How do you pass that? Oh, it's easy. I need to give twice of it. So it's 2x. Now let's test it. So this is how you progress with Cody. You get errors, you try to fix them, and voila. Everything worked. I get greens, and once I get greens, I can hit submit. And before you call me to sign your Cody check, make sure you submit that code because it makes it easier to check your results. And you hit submit. If you, for instance, wrote 3 by mistake, again, it will run, right? I mean, 3 times x is valid, but it is doing the wrong thing. It's not doing what the problem asks you to do. MATLAB cannot know that. Cody can know that. And it gives me that error. So I fix it back. And now I know it's going to work. I submit. And you have unlimited tests and unlimited submissions. Don't worry. If you do it wrong, get it, you can try until you get it right. And why I say submit is these boxes. When you call me, I'll see all greens and I'll check it for you. Okay? So submit it and then call me. Actually finish all the Codys and then call me only in the second hour of the class. So if I had a Cody problem for this one over here, for the hypotenuse problem, it would give me assertion failed because I wrote 3 and I would say, I made that wrong. I did that wrong. So I fix it and it would match, and apparently it needs to be this. So that is the difference between Cody and MATLAB. In MATLAB, you have to define everything. For instance, in Cody, you would have something like this. You never write functions. We don't learn them yet, but my output will be h, and my function, let's call it hypotenuse, right? And I'll give you an x and y. So if I gave you that x and y, what you need to do is you just get rid of it in Cody because they will be given to you. If I had another z, if for some reason, let's say it's not hypotenuse, but this is special calculation, some sort of weird calculation, which requires z minus 34. See, since they are not defined, that z is not in here, you still have to define z as, let's say, 5. Otherwise, it will give an error. But you don't need to define x and y. This is for Cody, not for MATLAB, because in MATLAB, functions, actually, you don't write functions like this. We will show you. You can't have these other stuff if this was a function. It doesn't work that way. I'm just giving you as an example. So Cody knows what results you should get. MATLAB doesn't know what results you should get. So that's why we use it. So this is pretty much it. I know it's a lot of information, but this very first zeroth lab, actually, you just try to get used to, what's going on and what these things are, how you use Citrix, how you use RaiderDrive, how you use Cody, how MATLAB works, how command window works, how editor works, what this current folder is, what workspace is, and all that. I know it's a little confusing, but it's very simple and you'll grasp it very quickly. And once you figure these out, you will solve those problems way faster. So make sure you never write your code in the command window. We always write our code in our editor. Our command window is just to check quick things or see our results and things like that. Our main code will be here, and the formatting should be like this. Your name, etc. The sectioning should be like this. If you don't put that space, it will give an error. Actually, you need to do this properly or you will lose points. As I said, semicolons is very important. Per problem, you need to have a comment. Tension. It can be one word if you want. That's fine. I mean, this is a function. So for each problem, and these are not considered comments. They are technically comments, but we want extra comments here. And make sure your code looks nice. It's sectioned out nicely. The defined ones are maybe separated from the actual calculation and things like that. All that good stuff. And make sure when you run it, it doesn't give an error. So when I run it, it just runs nice. So if I get an error, actually I should probably get rid of this function because it might not work properly. So if I run it, and if I get an error, make sure I should just go and fix all those errors and then run it. And then once I have my results nicely, everything is suppressed properly. This is X. Then I'm ready to publish it. Once I publish it, I go to Blackboard at the end of the class and I submit my work to Blackboard. Never forget these, okay? If you forget to submit anything to Blackboard, you will lose pretty much all your points. You'll get a 0. Your whole 2 hours will be gone. So make sure you submit your work to Blackboard at the end of every single lab. And if you got all of these, you're ready to go. Please practice, get used to it. You know, warm up to MATLAB, write some little codes and stuff so that your first lab runs like a breeze and it's easy. Thank you for watching. If you have any questions, you can email me, you can contact me, and I'll try to help. And see you in the next lab. And if I forgot anything, I will email you guys and let you know about the things that I might have forgotten. And if you don't understand something, if something's missing, just let me know. Once again, thank you for watching. See you next lab in our actual class in the lab. Bye.